Hi, everybody. Jason here from Murideo, and today's guest on the webcast is Jeffrey Boccaccio from DPL Labs. Jeff, how are you?
Hey, borderline perfect.
Yeah, we're close, right? It's great to see you. Great to hear from you again. We've been
Yeah.
doing kind of this ongoing HDMI lessons, if you will, for a few months now. I feel like, and I feel like they're going great. And thanks to some of the feedback from the viewers, we're going to continue doing these. People seem to love this stuff. I love this stuff, and I just love learning from you and talking to you. So thanks for coming and hanging out today.
Yeah, today we're gonna start from the beginning
Okay.
and into the hardware and into the logic, and it'll give the guys some really good ideas and thoughts of what's really going on.
Okay.
They just don't
Cool.
know what's going on in the bowels of the system, and
Sure.
they should know this because it'll help them out. So it's gonna be things they've never heard before,
Yeah.
and I made it really easy on the PowerPoint so they can easily understand it.
Okay.
So anyway, it's gonna
And
go real well.
yeah, and just in case if anybody is joining, and maybe didn't get a chance to read the description, the title of today's session is Starting the HDMI Engine. So one of the curiosities I've always had is, when you physically plug in an HDMI cable, what has to happen and in what order before we actually get an image on the screen. So we wanted to
Hmm.
kind of tear that apart a little bit, dissect it, and go over some of the things. And this is important stuff because, if things aren't happening, like let's say a hot plug, I'm sure we'll get into that a little bit later, there's no connection. So we just want to kind of drill that down for you guys, and take a look at what happens when you fire up HDMI. If you do have any questions throughout the presentation, there's a question box. Don't be shy. Type those questions in. We'll answer those as we go. And if we don't get to any of those questions right away, we will leave some time at the end. Sound good, Jeff?
It's great, man.
All right, rock and
It's
roll. So
great.
as soon as you're ready, let's share your screen and
Oh, okay. Let's go ahead and share. Let's
yeah,
see. What do I do? Let's see. You got to
we'll
give me a share button again.
and we'll start the geek out session. Yeah. Do you still have the presenter? Uh, Let me just make sure you do real quick. Stand by. And you still should have the presenter. Yep, you still have the presenter access. So you should be able to just hit that share screen button and let her rip.
Share screen. Let's see. Where is the share screen button? Hmm.
Check under your
Should
microphone button. There's like a icon that looks like almost like a little TV.
Oh yeah. Oh, there we go.
There we go.
I think that's it, right?
Awesome. That's
Super.
it. And we have
All
your
right. Let me.
beautiful gold logo there. DPL Labs, 48 gigs. When did you redo the uh, the graphic from 18 to 48? Pretty
Well,
recently.
yeah. We're this whole 48 thing is a major change,
Sure.
and the whole website's being changed, and we're in the
Yeah.
middle of doing that, and we have to change all of our test equipment.
Sure.
We have to change all of our fixtures. We have to change our procedures, and
Hmm.
now we have to get into copyright problems. But because of the labels that get put on the product to make sure that they don't get stolen, which they always do,
Yeah.
and people like AV Pro, for instance, they earn those marks,
Sure.
and it's not cheap to do that.
Nope.
And we spend a lot of time, a lot of energy, trying to keep that thing secure. So those brands get to use the capabilities of what DPL offers in the
Hmm.
test criteria, and then also we've added a lot of new testing, testing that nobody even knows even occurs because of the way the new system operates. And
Okay.
one of those big ones is on link training, but we'll do that
Hmm.
another day. But today we're going to talk about the HDMI startup engine, and what people need to understand first off is the HDMI system is a living organism. I mean, it's things have to happen. They have to happen in the right sequence, in the right
Hmm.
time. And if it's not done that way, you're gonna have another truck return. You're gonna have another truck call to get out to the
Right.
to the job site. And
Yeah.
we're gonna go through a little bit of that today with this startup engine. So I'm gonna teach you a little bit about the DNA on the startup, and then we'll go through a startup procedure on how it actually happens. And that way, there you'll know where you are in that sequence as you put in these systems.
Good.
We'll have some signs of troubleshooting so that you know if this happens and this happens, chances are that's happening. And it's not that long. It's not like it's going to take us an hour to do this. I made it very fast and easy to understand. So why don't we get started with that?
Yeah,
And
let's do it. I'm excited. What we do with HDMI on the Murideo side versus what you do, it's, I know there's for sure some things that cross over to each other, but I was really excited for this session myself just to sort of learn a little bit more. So again, thank you for being here, and I'm sure the viewees and attendees will get a lot out of this. So thanks
yeah,
again.
yeah, you're gonna get a lot out of this, and very happy to do this for you guys, Jason.
Yeah,
And you're right. You're right. Murideo is very parallel with what DPL does,
sure.
but we do it a little bit more on the hardware side,
Hmm.
whereas Murideo is more video centric.
Yeah, exactly.
And basically, our job is to make sure the damn thing works.
Yeah, I love
You
that.
know,
Yeah.
and the performance is going to be there. Just get it going, and the
Hmm.
performance will be there. Now, that's not true under 48G. That's not, and that's what we'll get into link training at another session.
Okay.
But today is about, you know, 1.2, 1.3, 1.4, 2.0, 48. They're all the same on this, pretty much. So let's get started. And yeah, the name of the session is starting the HDMI engine. And the first thing we're going to look at is what a signal configuration looks like in the HDMI interface. You got this cable, and there's a lot in the cable. But there's 15 pins, a lot of 19 pins. Out of the 19, there's only about 15 of them being used.
Right.
And there's a lot of common grounds too in there, so that there's a multiple pins are used for common grounds. So you
Hmm.
shouldn't scare you that much. However, there's still a lot going on, and so we're just going to run through this in a picture format. So every system starts off with an HDMI source,
Hmm.
a Blu-ray player, and a Roku box, whatever. And in that source, they have to follow rules. And then those rules are you must have some sort of serializing system.
Hmm.
And so they have a transmitter, an HDMI transmitter, in the back end of the piece. Let's say it's an Apple TV.
Hmm.
And what it does is it takes the actual video, and the video actually is generated more on a parallel base rather than a serial base. And this serializes the information so we can get it down the HDMI wire. And all the data is being streamed down that wire, one after another, after another, and after another. That's what serialization is all about. And in that processor, we have to then take inputs and get them into that stream. So the
Hmm.
first one, of course, is video, audio. We want to get audio down that stream. That's important. We want to get video down that stream, and we want to get control. Now, control is EDID, HDCP, and after Rev 2.0, it's called status control. And there's all kinds of things that happen under status control. In fact, if we did an analysis of all the failures that have come into DPL laboratories, and there's thousands of them, because all of our work we do with case studies. We don't just look at a spec and say you should be here. If AV Pro calls up and says, geez, we have a trouble with this thing, we'll take it in, we'll do a case study on it,
Hmm.
and then we'll fix it. And then we'll say, okay, this is why this happened. It's because you didn't do this, you didn't do that, that happened, yada, 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 and it gets corrected. We've done hundreds and hundreds of these. And this is
Sure,
what this,
sure.
this is what makes up the DPL process in testing. Because we're looking at what happens in the field, what happens to these guys, not necessarily what's happening in the lab when
Hmm.
the thing is designed and engineered. We want to see what it is
Right.
in the real world. So
Exactly.
the source starts off that way, right? This is what we
Hmm.
got. That's all we got. Now it's got to talk to the sync, or in this case, we're going to use the display. So on the sync side, well, guess what? Now we've got to deserialize this. So we got to change it back to what it was before it left.
Sure.
And then, so of course, we've got to output audio, and we've got to output video, and we've got to output control.
Hmm.
Well, if you took all of those case studies that we did and all the thousands of calls we received in the last 10 years, 80% of them are because of control.
Really?
Almost everybody says, "Oh no, man, my video. Oh man, the bandwidth's too low. I don't have a good cable for the bandwidth." And at first, we thought that would be true,
Mm-hmm.
But you have to remember, when we started at DPL Laboratories, we started it from our engineering firm.
Right.
So we have a freelance engineering firm, and we had a couple of very popular companies that everybody knows that came to us for, engineering, switchers,
Mm-hmm.
format converters, that type of thing. And we made these HDMI switchers, and we followed the book on this. I mean, we really did follow the book on this.
Yeah.
And lo and behold, it goes into production, and they start coming back. And of course, you got to take care of the account. So, okay, get them back and let's see what it is.
Sure.
And that's when we finally realized, because we thought it was going to be a video issue, and it wasn't.
Mm.
It was really a control issue, and then we went into Valums, and we went
Yeah.
into SDI and all those other things. Almost all of them had to do with control issues.
Man.
Yeah, and even in extenders, when you get in extenders, like even when you had an active cable or even an
Mm-hmm.
AOC cable,
Right.
most of the time it's a control issue. So, you know, don't get into the weeds on the video. If it's a video issue, you're going to see it's something like sparkles on the screen.
Yeah. Sure.
There's going to be obvious things that show you that it's going to be dead, but
Right.
control will also kill the system too, and
Mm.
we'll go through that today. So in order for this to work, we need some wires in between these two things. So the first wire, which is the most important wire we're going to talk about today, is power.
Mm-hmm.
And then it's right after the power goes out, the sync then returns a hot plug detect. This is the handshake. This is what lets the source know it's talking to somebody.
Mm-hmm.
So after that's done, the source turns around in their control. They got a control process in there, and they say, okay, we've got to now blast out some stuff, and they do that by way of the DDC channel.
Mm-hmm.
And the DDC channel is basically an informational channel, and it's the control channel. So the control that we talked about in both the input and the output,
Mm-hmm.
that runs down that DDC channel, and it's very, very important. A lot of people don't think about it. We see so many products come in where, especially in wires and cables, Jason,
Mm-hmm.
they take those DDC line and they make them into crap because it's just
Yeah.
it's a low end. It's only 100 kilohertz. Now 100 kilohertz is high. It's a lot higher than audio, right?
Oh,
But
sure.
we're
Yeah.
dealing, we're dealing in the gig range on HDMI. So 100 kilohertz is
It's
nothing.
nothing. Yeah. Yeah.
Uh, but there are some rules under I squared C that many people don't follow. And because the I squared C interface was made by Philips, it wasn't made by HDMI.
Mm-hmm.
HDMI is using it, and they call it DDC.
Could
And there's
Jeff?
certain numbers. Yeah.
I'm sorry. Could we just briefly, if you can do it briefly, in case anybody's not familiar with I squared C?
Okay.
That's just the language. How would you describe that?
Okay. It's a protocol. So it's a protocol that Philips built many moons ago. In fact, it was so long ago. I was still in college.
Oh my gosh, they had
I
college
mean, it
back
was
then?
a long, and they did it for IBM. It was all for computers and all that stuff. What it was designed for, it was designed to talk to chips
Right.
on a board. So how far are they away? 2 inches,
Yeah,
three
maybe,
inches.
right?
That's really all. So what you'll do is, like, let's say we built a format converter, right?
Mm-hmm.
So Analog Devices makes a chipset that does format conversion, and they have an I squared C input to it, and then we have a microcontroller in there that we program, and then we talk to that input by way of I squared C. It's just a protocol. It's just a language.
Good.
And when we say to it, go to go to S video, or go to RGB, or change
Mm-hmm.
your resolution. We can do that with all this data, and it's just all clockwork. So there's a clock and there's a data line. They have to
Mm-hmm.
synchronize with each other, but the
Right.
integrity of that data line's got to be pretty good. And that's a whole nother story. We'll do it maybe one other time. But
Yeah.
what HDMI did is they gave the specification of that in capacitive loading. Now, that's a good idea, because when wires like this become capacitive, they can really raise havoc on the bus. And the way they do that is they slow the rise time of the data. So instead
Okay.
of being a perfect square wave, it kind of looks like a roundy wave in the front end of the data.
Got it.
And there's only so much of that roundy wave you can do.
Mm-hmm.
Well, when we measure that at DPL Laboratories, we don't look at the capacitive loading. I mean, that's like archaic. Nobody does that.
Yeah.
What you do is you look at it in the rise time. And Philips they have a spec just for that rise time. And it's tight. It's a very tight spec. And so if the wire's not made right, or let's say they put those wires too close to the outer shield,
Right.
at 100 kilohertz, the capacitive loading of the shield will suck that information into the shielded ground. So it will cause those rounding effects to occur.
Mm-hmm.
And then there's DC levels that also pertain to the 5-volt power. We'll talk about that later. So
Okay.
this I2C bus is very vulnerable, and unless we very much take care of it, it will raise havoc. And let me tell you, we get into 48, this thing is packed with information.
I'm sure. Yeah, it has to be. There's so much more stuff going
Oh
on.
yeah, I mean, you've got all these different data rates that they have to pick from.
Right.
And then they've got, of course, I'm going to bring it back again, link training, which happens over the I2C bus. So it's a very important point. But thank you. I hope that gave you a little bit of it anyway.
No, that was great. Like I said, I'm not an engineer, I'm not a programmer, so just learning, even if it's the basics about this stuff, I always enjoy. So thank you for thanks for breaking that down.
Yeah. Then we got more stuff, right? So we have video, of course. So we have these. This is in data channels. We call it D0, D1, D2.
Right.
And then, of course, in order to synchronize all this serial information, we have an onboard clock.
Mm-hmm.
And at Rev 20, that clock is running about 150 megs. So that's the package. That's what you guys are dealing with every day.
Right.
Now, when we go to 48, it changes a little bit. So we'll go to 48 now. And you see, the only thing that really changed was the clock.
Right.
The clock turned into D4. So before, in 6 gigs, let's go back to that a second. In 6 gigs, each one of these channels had 6. I'm sorry. In Rev.2, each channel had 6 gigs.
Mm-hmm.
So we have 3 channels, that's 18. That's why everybody knows what 18 gigs is. But when we go to 48, each channel is now 12.
Mm-hmm.
So now it's 12 times 4 is 48. So that's how they get the 48 out of it. So we doubled the data rate on those channels.
Mm-hmm.
We're asking a lot here, because you have to look at the envelope, and the envelope is now really big.
Sure.
Because we still have to support 1.3 stuff.
Yeah, good point.
In fact, we still have to support 1.2 stuff.
Yeah.
So we have to go all the way down to 1.65 gigs.
Mm-hmm.
Okay, it's all the way up to 12 gigs. So the transmission line has a lot to cover, and they're not exactly linear as per frequency response. If you ever looked at an I2C, or I'm sorry, an insertion loss curve, which you do, you got the equipment to do that.
Yeah, we can do that.
It's pretty obvious. You see these things start rolling off. But then there's a little thing in there called Nyquist, and Nyquist in many cases helps us, and in some cases hurts us. Again, that's another discussion, another day.
Yeah.
So that's what we have. That's how what the configuration looks like. So let's move on. So we have 5 parts that make up the system.
Here, real quick, Jeff. There was a question from one of the viewers. If you go back one slide, the question is basically, when we went from 3 to 4 data channels, the 3 that remained, how did those all of a sudden go from 6 gigs to 12? Is it a thicker gauge wire? Like how did they pull more bandwidth out of the 3 that were already there?
Okay, so now you're talking about the actual interface. I was going to say they went to 12 just because the processor goes to 12.
Oh,
but I see
okay.
they're trying to find out, how do you convert a 6 to a 12?
Yeah, exactly.
It ain't easy.
Yeah, right.
I mean, we see them here all the time, and it's amazing the dynamic range of quality that you get out of these folks. And then you've got to look at the consistency between all 4, because we'd like to see them, within a certain margin of operation. And our new test equipment does a real good job at that. We'll another session, Jason. Right? We're going to look to that.
Sure.
But let me answer the questions for him, and that is that in the older days, we were looking for 1.65, 3.4, 6 gigs, and even at 6 gigs, you got a little testy, right? But in the older days, it was stranded wire. Typically, they twisted it because to make it more supple, make it more flexible. But as you start going up in that data rate, you can't do that anymore. You've got to get into solid core cable.
Solid core, yeah. Yep.
Sometimes you plate that in silver
Mm-hmm.
because of skin effects. So the high data rates will travel on the outside of the skin.
Mm-hmm.
So there is some there's some science to the copper. There's also science in the dielectric around the copper. And there's also another science around the dielectric, or I'm going to call filler,
Mm-hmm.
around all of them.
Right.
Because, again, where we have spacing has to do with capacitive loading. And capacitive loading will not only affect I squared C, but it'll also affect the video. So if the guy doesn't know what he's doing, and trust me, there's a lot that don't.
Yeah.
I mean, we get him in here all the time. And, they're really nice people.
Sure, of course.
They just don't know, and it's...
Yeah.
And what we do for DPL, and as AV Pro knows, is that, when something comes in and we see something that, guys, you can do this a little better. Let me make a suggestion.
Yeah.
And the guys that are sharp, like AV Pro, they just suck it up. They just say,
Yeah.
"Okay, oh yeah, we want ours best."
Yeah.
And I'll say, "Okay, this is from experience. I can tell you what you should do," and we tell them what to do. So, the whole idea of how to make that wire better has to do with the science behind it, understanding the science. And remember, we're in the RF area now.
Mm-hmm.
And in our world, in the engineering world, that's called black magic.
Yeah.
So this is all black magic. It's kind of like you think about your cell phone. How does it work?
Yeah.
Jesus Christ, I'm in an elevator and I can get this thing to work. But I
Still
used to have
works.
an AM radio and it was never work, right?
Yeah.
I mean, and there's a science behind this. It's not like it's magic, So, the guys have to know, and some companies are better than others. And some companies try to get away with using older technology.
Mm-hmm.
And what they'll do is they'll come in with a 1 meter cable where with some older technology, and and it might just eke by,
Yeah.
but you go to 2 meters, it's in the dirt. So what they do is they go get a 1 meter certified, and then they start making all these different lengths.
Yeah. It's not. Yeah.
I mean, there's all things that go on. So I hope I answered that for him. And
No. That's great. Thank you.
if he needs more information, write to me. I'd be more than happy to explain
Yeah.
that to you.
Sure.
So then we have, okay, so I'm going to move on to the 5 parts that make up the system. And the 5 parts is basically what we all talked about. And that is that the first one, which is the most important one, is power.
Mm-hmm.
You guys don't understand the ramifications of this power line because it will raise havoc. And guess where it raises the most havoc? On the DDC line.
Sure.
So, when I say to you 80% of the DDC problems were there, well, a lot of those were related because the power was wrong.
Oh man.
See, it all intermingles itself. And if that's wrong, well, then also a hot plug gets screwed up. So that's another you've got to have the 5, and you have to have 5 volts, the hot plug.
Right.
If you don't have these two, you might as well go to sleep and go to bed, maybe go get a beer. Because nothing's going to happen,
The
And then
sorry, I was just going to say real quick, the one thing that we have to talk to people about a lot is, something as simple as making sure the cable's plugged in all the way. It sounds like overly simplified, but that pin is recessed. So
That's
it
right.
might seem like you're plugged in when you're really not. So we have that whole joke in the tech world for almost anything, unplug it, plug it back in. But that is especially true here, because if you don't have that cable seated just perfect and that or that pin's recessed, your number one problem that you're talking about right now shows its face.
No power. And they recessed that, on purpose because they wanted to make sure all the data lines were hooked up before power starts.
Yeah, right.
And it was a good idea, just that some people, you're right, they don't stick it out all the way, So let's see. The other piece of information is the DDC channel. If you don't have the intelligence, go to sleep. Ain't nothing gonna happen.
And that's then, that's EDID and things like HDCP, right?
EDID, HDCP, and status control. Status control, it came in under 2.0, and it's got all kinds of extra stuff in there. So this is very important channel. Then, of course, TMDS video is important, and FLR is important also under 48. So the video is a major need for this thing to work.
Yeah.
And last but not least is timing. We're operating so fast that the skew or the time differential between all these wires. Now you have to remember, there's not 4 wires.
Right.
There's not 4 wires, right? There's 8 wires
8. Yeah.
because it's differential.
Right.
So, but yeah, well, it's 6 with the ground, right? But in the signal wires, it's differential. So there's a plus and a minus, just like balanced line microphones or balanced line turntables or whatever you want to call them, right?
Sure,
So for every channel, we need 2 channels. So those timing numbers are very important. And if you go out of those specs or get out of the range a little bit, you're in trouble. So this is what we call making up everything. And the HDMI 5-volt line, 5-volt is the lifeblood of the system. And let me just run through this very quickly with you so you can understand how it works. We have 5 volts that goes across. Okay, let's get rid of the sinks and sources and stuff. And let's look at this directly. Let's say we had a 5-volt line that was 100 meters long, 300 feet, okay? So if we put 5 volts in the front end of that, I want everybody to watch this very carefully. It's a trick question. We put 5 volts in the front of that. What do we have on the output of that?
After 100 meters.
After 100 meters, what do you think we got on the output of that? That's a long way.
I'll take a stab and say 4.25 volts.
4.25.
Total shot in the dark.
Well,
Total shot in the dark.
Shot. Okay. Anybody else want to comment? Anybody else want to write a note in and say, well, what do you guess?
Yeah, Tom. Tom's been very vocal with questions and stuff so far. Tom, if you have any guesses, let's play a quick over/under game. I'm at 4.25. Let's see if anybody else has any guesses. We'll give them a few seconds here to chime in. People might be being shy. Nothing yet. Let's just keep moving. We'll see if anybody does.
Okay, you want to hear the answer then? You ready?
Let's do it.
It's 5 volts.
Oh, I thought we'd lose some.
Why? There's no load. The only load is atmospheric conditions. So this thing is just hanging. It's hanging in the wind. And this is the most important point because you plug it into the source, and before you plug it into the TV, that 5 volts is just sitting there at 5 volts. So if some nerd goes in there and measures the 5 volts to make sure it was there, they're going to measure 5 volts.
Right. But it's not plugged in anything yet.
It's not plugged in anything yet. So
I totally overthought that. That's funny.
There's got to be some current. It's kind of like, it's got to have certain numbers, and the reason why is this? It's because there's no load. So let's look at this now. We threw a load on this. So here we have a 5 volt source, but notice it only can support up to 55 milliamps. Now, a lot of guys aren't going to understand this, and let me just give it to you really basic so you can understand. You got your car, and you got a 12 volt battery in the car.
Right.
So, you want to make sure your starter turns in the middle of the winter, so you go get, a gazillion amp battery, right? And that way you got that power behind it, right? Well, the power behind it is the current, not the voltage.
Right.
The voltage is the voltage. That's the potential difference. The current is the current. It's kind of like the size of the pipe. How much water can you feed through this thing? Well, if you had a low battery and you measure it with a voltmeter, remember these voltmeters are like mega ohm impedances, so it's just like working in atmosphere. You'd probably measure 12 volts. But you go to turn the car on. Well, gee, your radio comes on. Gee, my idiot's light comes on. But I go trying to start on, you get this. There's not enough current to turn the starter. So you've got to charge it up or get a new battery or whatever. So it's the same thing here.
Gotcha.
You need to have the 50. You have to have the 55 milliamps, or it will not start the engine. Now that 55 milliamps is the minimum.
Minimum, yeah.
The minimum, okay. So like one of the worst ones out there, Apple TV. Really? Apple TV. I mean, they're running when you load them. They can pull as much as they supply as much as maybe 70 or 80. And you say, well, that's good, right? 50. That's better than 55.
Yeah, but
you put an AOC on that thing. A good AOC. A typical AOC is going to pull 100.
Yeah.
So that's why we see all these problems with AOCs working with Apple TVs because they're killing the power supply. It's out of spec. These AOCs are out of spec.
Yeah.
And this is what you got to watch for, because, you say, oh, geez, I tried it in the shop and it worked fine, but every source is different. So you can buy a Samsung that maybe has 55. You may have an LG that has 240.
Yeah.
We have an LG here that does almost 300.
Well, and that's not regulated, right? So the manufacturers can kind of do whatever they want.
As long as they're over 55.
Yeah. Yeah.
But we don't know that. And of course, the lower the current, the cheaper it is to
Mm-hmm.
make. So,
Sure.
and of course they always go cheap. So this is a major problem for everybody. So once you put a load on it, it gets to be a little bit of a testy. But now I'm going to tell you some real interesting things. So here's our current draw, right? And you see, now we go less than 5 volts. Now we're
Right.
some number less because we're drawing current now, right?
Mm-hmm.
Well, the TV on its own, when it's turned on, draws 10 milliamps. So you don't have any but 45 left.
Right.
We're already sucking 10 out of it.
Mm-hmm.
So
That's
now
20%
you think about
almost.
your AOC. You just lost another 10 mils.
Yeah.
But this is where the fun comes in. You ready for this one, guys? Because none of you know this, I bet you. When you turn the TV off,
Mm-hmm.
it draws 50 milliamps. Did everybody get that? You
Trying
actually
to,
you're drawing more current through the bus when the television's turned off.
there
So
has to be a simple reason that I'm not clicking.
yeah, it's
I'm
very
not
simple.
having the light bulb.
It's a very simple reason, because what HDMI did is they put that 5 volts on there, not only to do the handshake, but they did
Mm-hmm.
that so that they could supply current into the TV set. So when it's off, if they have any control processing going on and there's no power
Oh,
supply
yeah.
for it,
There it
the
is.
5
Yep.
volt 5 volt runs it. So it
Yep.
draws more. That's why it's 55 milliamps. Okay, so that gives you an extra 5 milliamp buffer.
Mm-hmm.
Well, that AOC we just talked about, well, we just blew us out. We just blew the doors out.
It's toast. Yeah.
It's toast. So what happens is people say, "Well, geez, I don't understand. The system's not working right. I don't understand. I plugged it in, I turned it, it doesn't work. I don't get it. But if I unplug it while it's on and I plug it back in, it comes on."
Yeah. When it's turned on.
Uh, let's think about that a little bit, because it will also affect the I squared C bus. We'll cover that
Mm-hmm.
later on. But you see, all of these things affect those, because the 5 volts on the source is the 5 volts that feed the DDC line. So if that 5 volts drops, the DDC's amplitude drops.
Mm-hmm.
And as the amplitude drops, the timing gets longer. Everything it's
It's
just
all
a
related.
continuous. It's like
Yeah.
an avalanche. Because
Yeah.
once you lose one, it affects another one and another one and another one. Meanwhile, you guys are out there trying to troubleshoot, and you get some clown that tells you that, oh, the reason why that's happening is because you got to turn the equipment on in the right sequence.
I've heard that a million times. Yeah.
I mean, do you really think they would have designed it that way? I mean, come
No, no
on.
way. Yeah, no
But
way.
somebody had some luck.
Yeah.
Oh, I did this and I did that, and then they spread the word, and all you guys go out there and try all these different hocus pocus measurement jobs,
Mm-hmm.
and it's not going to help you.
Yeah.
It's science. It's not pixie dust. It's science.
Yeah.
You know. So okay, so let's move on. So we have this 10 milliamps, and we have 50 milliamps when it's turned off. So now, if we add more current, right? Let's say from an active cable,
Mm-hmm.
when it's on, we're okay. Oh, if we add more current, how many times have you seen distribution amplifiers, where they don't have any power? They use the power off the bus.
Yeah.
That was really big back in the day, right? And you don't see that too much now. People have at least wisened up. But even still, people are always doing this. They're putting LED flashers on them and all kinds
Mm-hmm.
of nitwit stupid stuff. You're crazy because you don't know what your source is supplying.
Right.
I mean, it's got to be at least 55. But like I said, some are low, like Apple TV, real low. But then
Mm-hmm.
you get something like we have this LG in here, 300 mils. That's like car engine stuff. I mean, you can run anything off that thing, right?
Yeah.
And so you've got to be careful on what you're putting into the system. And anyway, that's why it's so important. So let's look at what the minimums are. So you see, if you look at all these currents, the danger begins, because it could fail, and it could fail after you leave.
Mm-hmm.
I mean, you can be right on the edge, and then the guy turns it off, turns it on again. Oh, gee, the
Yep.
crap hit the fan, right?
Mm.
So this more current really causes trouble. And but what about voltage minimums? Well, you can't. If we only had 4.8 volts coming in, that's only 0.2 of a volt smaller than
Mm-hmm.
5, right? Well, what does that mean? I can't have any less than 4.7 at the sink. That's spec.
Mm-hmm.
So the TV needs 4.7. That's only 300 millivolts. That's nothing.
Mm-hmm.
So which means that you only have a 1/10 of a volt drop that you can deal with. Now you think about that over 100 meters, and you put a load
That's
on it.
tough.
You're screwed.
Yeah.
You're
Yeah.
screwed. Anyway, I just want to
So
drive that point home.
no, that's good. And that honestly sounds like, to me at least, and tell me if I'm, at least on the right island, but this is why with HDMI in general, with a passive normal HDMI cable, you want to limit it to 4 meters or so, right? Because is this what's causing those long
Mm,
cables to not work, or am
mm.
I off
Nah,
there?
I mean, not really, because typically when they go long, the gauge increases.
Yeah, I've seen
And
some big fat ones. Yeah.
fortunately, our friends in the Far East have figured it out,
Hmm.
through trial and error.
Sure.
And they say, "Oh no, go long, must be fat."
Yeah. Yeah. Yeah.
I mean,
It makes sense.
that's what the problem there is. It gets less flexible.
Right.
They get to be these honking poses, that
You can't bend it anymore.
can't
Yeah.
bend it anymore. So how about the arguments? So we have loading issues, which of
Hmm.
course affects the sink. It affects active cables. It's affected by accessories. And
Sure.
then we have voltage levels, and that affects the source voltage and affects the sink voltage. So
Hmm.
all of this stuff happens just because some nitwit didn't do his job
Yeah.
planning out the system. You've got to plan the system out. And voltage is the key ingredient. Okay. How about
Is
hot plug?
it?
Let's what?
I was just a question on that. With something that has low current, like your example with the Apple TV, um, is there any advice to avoid these types of issues that you can think of?
Yes, there are. There are ways of curing that, and that is by using external power. Now you
Gotcha.
can you,
On the
you can
cable.
do that. You can do that, but you got to be careful because,
Hmm.
and people have already done it. But what happens is they take. It's kind of like, okay, we'll go back to the car again. Okay, geez, I got this battery. It's dead. I'm in Walmart parking lot, and I
Hmm.
see this guy, this Walmart shopper coming along, and I said, "Hey, can you give me a jump?" The guy goes, "Sure." So he opens his hood, you open your hood, and you hook up your jumper wires,
Hmm.
and he starts his car, and now that voltage is going into your battery because
Right.
your battery has got the potential difference, right?
Hmm.
And then you start it up. But what would have happened if the guy's regulator went bad and his 12 volts went to 30?
Oh, bad
Bad
news.
juju for your car.
Yeah, it's not going to go well.
Okay, well that's what happens when people put these 5 volt lines on because they literally put them on in parallel with the 5 volt line.
Hmm.
So now you plug it into a little 5 volt wall wart, like a USB wall wart or something like that,
Sure.
and that's okay. That's okay. But if that wall wart decides to go north, for say 6, 7, 8 volts,
Yeah.
it'll backfeed back into the source and kill it.
Oof. Zap.
Right. That's bad. So you got to
Yeah.
have one. You got to have one of these things that has a differentiator on it, where it knows I'm gonna take this one over this one. This one's
Hmm.
giving me enough. I'm doing fine here. Okay, I need more. Go to this one. And they are out there, and and they work. So
That's
that's
good
the
to
way I do
know.
it.
So there you
Okay.
go, guys. If you're having a lot of problems with Apple TV, try an active cable. See if that helps.
No, not an active cable. You gotta add external power,
Oh,
and you can do.
I missed
You
that.
have to.
Sorry.
You literally go out and get an external power supply, get an adapter that they make now. They've got them, they're female and male adapters,
Hmm.
and it's got a little wire coming out with a USB on it, and you plug it in series with your system, and you plug it in, it gives you power.
Got it. Do you just so I can maybe look up and share with folks? Do you have maybe a name of that we could share? Or
I don't. I don't.
that's okay.
Um, but I know that AV Pro's got one.
Okay, cool. There we go.
So if you want to, you can
Yeah.
ask Matt about it. I don't care.
Yeah.
But it's great. It works absolutely great. So
Awesome.
the thing is be careful with the power, and don't mess with it, and understand that it's it's the right of every source product out there to be able
Hmm.
to produce 55 mils. It's not because they're doing things wrong. Okay,
Right.
let me get going. We're going to get late. So
Yeah, no, it's okay.
we got 5 volts coming in. This is our hot plug detection now, right? But guess what happens to the 5 volts when it hits the sink? But you know what
Well,
happens then?
by the time there's a load, you'd think it would drop, right?
Yeah. Okay, let's assume everybody's happy. Let's assume we got
Yeah.
a good source. We don't have any real loading problems. It's coming in, say, 4.9. It enters the sink. It's
Hmm.
seeing 10 milliamps in there. What happens to it after that?
If there's that low of current, I think you'd have a failure. No?
No, the current's actually okay. No, what it does is it goes to a little resistor
Okay.
and it turns around and it fires hot plug.
Oh, okay. I gotcha.
Okay. So without the 5 volts, you won't get hot plug.
Sure.
But notice that little thing I have over here. Let me see my cursor. Oh, yeah, here it is. What did I do? Go backwards on this thing? Yeah, I did. So you see right over here where
Yeah.
this is a 100 millisecond delay line? If you don't have a tenth of a second delay
Hmm.
between the time the power leaves your source and the
Hmm.
time the hot plug enters the source again, the system won't work.
Yeah, that sounds very reasonable. There has to be a tiny delay in there. Things will get jumbled up and failure, right?
Well, you'd think that it'd be the other way around. You think you want less than 100 milliseconds, but they want more than 100 milliseconds.
Headroom, right?
Uh, well, I don't, I don't really know why they did that,
Yeah.
but they did. And so a lot of things happen here because sometimes a guy will call up and say, "Geez, I only got audio. I don't have video."
Hmm.
Or I got it's funny looking that the colors are different on the screen. All
Hmm.
kinds of different problems, and
Sure.
they plug it in, they go back and forth with this thing, they can't fix it, so they call us, yada yada yada. And there's an easy way to judge if this is working right, and that is what you do is right over here, right about in this area, you
Hmm.
take that and short it to ground.
Okay.
You hold it on the ground for a second or two. It doesn't matter. You can hold it for a year. It doesn't make any difference. And then you let go of it. And when you let go of it and the system comes up and it runs, the display is not delaying long enough.
Oh, sure, sure.
And we see this all the time, all the time. So now there's actually a couple of products out there that institute a delay line, an extra like 100 milliseconds.
Yeah.
Who's going to know?
No, yeah,
I
I
mean,
mean,
who's
it's
going to
so
know
fast.
200 milliseconds? Give me a break.
Yeah.
HTCP takes longer than that.
Yeah,
So,
exactly. Exactly.
so
Is that 100 milliseconds? Is that standardized in the HDMI spec or?
that's in the spec.
Yeah.
That's in the spec. Okay, so then we have EDID, and the
Hmm.
delay must occur, or you don't get this ADID. You got
Right.
to have that delay line. Okay, so on DDC, this is easy. DDC is another channel in here. We've looked at this before. Let's look at
Hmm.
this by itself. It comprises of 2 channels like this, and one of them is a data line, and one of them is a clock line. That's all that's to be said about that, because that's a whole other discussion.
Oh yeah.
Okay,
Yeah.
so now let's look at what this whole thing means. I call it the HDMI collective. This
I
whole
like that.
interface is the HDMI collective,
I
and it
like it.
all comes down to the HDMI house. So I
That's
call
cool.
this is the collective. So you
Yeah.
see, we have voltage as part of the roof, and timing,
Yeah.
and video's
Sure.
the main beam, and all this stuff.
Yeah.
You just take one of these out, and you're gone.
Yep. I love I love your animation. That's awesome.
You, I mean, you go in what we call a bad day,
Yeah, that's not going to work
and,
out well.
and not only that, but as we already talked about, the actual operation is judged by all of them,
Hmm.
because all of them can affect another guy.
Totally.
So you could be there, and the thing is, he's dead. Where do you go?
Yeah.
How
Where
do
do
you
you start?
troubleshoot this, right? So,
Right.
and there are ways to do that. Okay, let's talk about starting the engine. So here's a Blu-ray player, and
Hmm.
here is a display. And so what happens? Okay, let's turn it on. So the first thing we do is we look at the queen.
Hmm.
So that the Blu-ray player is the queen. It controls everything. not the display, the source. And so the first thing it does is it sends out, guess what? 5 volts.
Yes.
All right. So the 5 volts leaves the queen, goes up to the display, and turns it on. So now the TV is there. It's got some supply voltage coming in. Everything's cool. So the next thing is hot plug. Hot plug then comes in, and what happened to that? What happened to my animation on hot plug?
Oh no.
Oh no. Okay. Hold on. It's because I'm using HDMI. That's why. Okay.
That's probably why, yeah. By the
So
way, is your caricature of the Queen, is that approved by the royal family or
I don't know. I just stole it.
kinda...
So then we got hot plug. Hot plug leaves the system, and there has to be a delay, and then it returns back, and boom! Now both know they're both talking to each other. Step 2, step 3, EDID. We talked about this earlier. That's the extended display identification. It then gets sent up, and it goes into the display, and it says, "Hey, what do you got?" And it goes through all this laundry list of stuff and decides what the two pieces can do. Okay, then we have our last one, which is HDCP, and that's our content protection. It leaves, it goes up, and it looks for a key. In this case, the key is 314. It takes that key, sends it back down, goes in, and boom, we get a picture.
Yeah.
So we have to go through all of this, and we got to hold those specs in order to get the system to start. And underneath under 2.0, before 2.0, these keys were changed every couple of seconds. And now after that, of course, it changes. It's very manipulated now. So they really don't want you to copy this. You know?
Yeah, they're really trying to keep us out.
Okay.
Isn't just a curious question for me, and I think I just recently read this in one of the HDCP papers I was reading, is that key, it's like something like 40, or gosh, I can't remember. You can help me with this. I think it's like 23 or 40 characters long or some crazy string.
I don't remember. It wasn't originally. It wasn't much at all.
Oh yeah.
Originally, it wasn't much at all. But after when it gets to status control, I think it went up. It goes to a formulation package called hash.
Yeah.
And this is going on itself. I'm not doing this.
That's a whole cryptography.
That's the end of the presentation. And if you do your job and you listen to what we say today, I'll see you at the top.
Yeah.
By
the way, are you making these graphics? Because I love them.
Yeah, I put them together.
That's cool.
They're kind of fun to do, you know. But
no,
I do so many presentations around the world, and I'm always doing cool animation like that, you know. So
yeah,
and you know, it's more fun to watch it, and you learn more from it. And I hope everybody today that watched this today got a good understanding of how this startup works.
There were a few questions that came in. Tom, by the way, I must have missed this. He had guessed 2 volts on our little pop quiz earlier.
He went south on us, didn't he?
But okay, Tom, so there's. Oh, go ahead.
I was going to say, but Tom, you do understand now without a load.
Yeah, I mean it's electricity 101, right? Okay, so we've got 4 other questions. One's real simple, and Jeff, this is totally up to you because it's your property. But will the slides be available?
We typically don't do that.
That's okay.
But
because we have this video, it's going to be on YouTube.
So that's
okay.
So you can watch it on AV Pro's video set. That's right.
No problem. Okay. This is a really good question. I think you'll find this interesting. HDMI 2.0 is 18 gigs, whereas HDMI 2.1 is 48 gigs, almost 3 times as much. Why is the new standard called 2.1 and not 3.0 when HDMI 2.0 superseded 1.4? That was from 10 to 18 gigs, so not even twice. Why did the name not go to like 3.0? And he says at the very end, is this some kind of conspiracy or am I crazy?
I think they just try to screw us up.
They're trying to confuse everybody.
I have no clue. When I heard it was 2.1, when I heard it was 2.1, I said, "What are these guys doing?" You know,
why is it not 3.0?
I mean, help us out a little bit on this. And you know, they don't like us to use that. They don't like us to use the revision. So like when you don't. Yeah. You have packaging for your products. They don't want you to put 2.1 on that.
They just want
They
you to
want you to
scan
put
less.
Ultra HD. That's what they want.
Yeah, that's right. They want the, yep, with the QR
I
code.
mean,
Yeah.
you know, I don't know, you know, I don't know that, and they botched that up really anyway. You know, that whole QR code thing,
Yeah.
because the whole idea was, so many people were having their products tested, and then they only test one, like I told you earlier, and then they called the golden sample,
Right, right.
and then the others don't go through. So what they did is they made these stickers they put on there, and the stickers have these QR codes on them, and you
Right.
could tell who the company is and all that. Well, you really don't, because if any brand that gets that's buying it from the Far East, if the Far
Mhm.
East does the test for you, your name doesn't go on that.
Yeah, yeah, that's a
So that
good.
means that anybody in China can be taking those things and using them anywhere.
Got it.
It's and now under 48, it's even more critical
Oh yeah,
that you
sure,
make
sure.
sure that product has the right certification. So,
Next question. I
yep.
regularly read EDIDs from TVs that I test and review. Before the readout, I always set the HDMI parameters to enhanced, which makes sense, especially with the newer
Yep.
TVs. I usually get 1190 megahertz as a maximum pixel clock. Can you confirm or deny that this is the maximum pixel clock stipulated by HDMI 2.1? Unfortunately, some TVs show the maximum pixel clock of only 600, even when they're in an HDMI 2.1 mode. Does that mean that the 2.1 ports are somewhat compromised? Catch all that?
And what was I got it. What was the first number?
So he says
He starts
when he
off with
sets, when enhanced, he usually gets 1190 megahertz as the maximum pixel clock.
what? It could be.
Yeah,
That could be. Yeah. I
maybe.
mean, you have to remember the clock's embedded now, and
Right,
so
right, right.
before we used to have that outside clock, it was very simple to track it.
Hmm.
But that clock is constantly changing now,
Yeah.
and I don't know that answer, but
Okay.
I'll find out.
Yeah, that's okay. Tom,
I'll
if you
just
could, just so we don't lose this one through the cracks, just send Jeff or myself or both of us a message
yeah,
about this question, and we'll dig into it a little bit more.
that's a great
Um,
question, Tommy.
yeah, it's an awesome question, and that's one of those things too. Like unless you're really digging deep into this stuff, like no one else would know but you if you're doing this kind of testing. So yeah, it's a very
Yeah.
specific, very good question. And then last one, it looks like, and if anybody does have any last minute questions, go ahead and throw them in now. When a user changes the HDMI 2.0 parameters from standard to enhanced, the EDID for the maximum pixel clock jumps from 300 to 600 megahertz. Why doesn't HDMI always operate at maximum? Some users may forget to switch to the higher operating mode, for instance, and will only get 422 instead of 444. Is 600 megahertz more power hungry than 300 megahertz? And are there any considerations to operate at 300 megahertz in standard settings? So it sounds like there's a few questions in there. Do you have any initial thoughts? Maybe we can break down the
Yeah.
many
Well,
questions into one individual question.
you have to watch yourself on that, because the pixel clock is directly associated with synchronization.
Mhm.
So, and there's a lot going on. I mean, there's a lot going on in synchronization, and I think most of those pixel clocks are judged by their frequency rates by way
Mhm.
of sync. So, I don't know if I don't think you could. I could tell you right now that you could never take um, a system that's demanding at a 600 pixel clock and give it
Right,
300.
right,
It'll
right,
never work. I mean, it'll never work. And we have that here in the lab in a way because of our equipment.
right. Hmm.
Our equipment has a separate system and clock, and that to give you an example, the system clock is 181 megahertz for one
Okay.
particular frequency. If that's 181.4, I lose sync.
Oh, it's that tight, huh?
It's that tight. So now
Wow.
this equipment we have is way out there. It's data center
Oh,
stuff. So it's really
sure.
esoteric. But it just goes to
Yeah.
show you though that synchronization is all of it. But I think it's probably synchronization. But I could look into that too. I think it's a good
Yeah.
question.
And that was actually another one from Tom. So yeah, Tom, feel free, send us a message on that one too
Yeah,
if you need some more
Tommy. Every time you have
clarification. And
when you have questions, Tommy, bring them in, because That's how we get it out to everybody else.
Yeah,
We first find out what the story is, and then we announce. And what I'll do in that case is I'll respond to you, and of course I'm going to respond to Jason.
Yeah, excellent, excellent. Well, guys, that's it. I mean, that's right at an hour. Very valuable information. I think the big takeaways here are make sure the cable's plugged all the way in, so you get your hot plug and you get your 5 volt. That's going to be one of the big ones. The 5 volt seems to be what breaks a lot of things because we don't get DDC data. And there might be some times where you have sources that only give you so much current to make all that fire away. And if you, again, I didn't even bring this up before, but the example you showed before with your graphic was a source straight to a TV. We didn't even get into talking about what might happen from manufacturer A of an extender versus manufacturer B of a receiver, because I'm sure throw more things in the signal chain just makes it even more complicated. So,
and
yeah.
what a lot of people don't understand also is that we have to look at it when it's fully loaded.
At
So
the
that
very
means
end, right?
that means every channel is maxed. So
Right.
that means that every digital channel has to be at rail.
Mm-hmm.
And you got and the I2C clock's got to be running. You've got to be moving data, and if some idiot puts LEDs on it, they got to be on.
Right.
So you know what you're dealing with. And I guess, like I said, we get that all the time. Now a lot of guys these AOCs have gotten really good now. They're getting down to into the mid 60s.
Yeah.
Not good enough, but in another, I don't know, 6 months, HDMI is changing the rules, which is going to save a lot of us a lot of problems. They're upping it from 55 to, I think, 320 milliamps.
Oh wow, so that make it a big jump.
So that'll solve all these low current issues.
Would this conversation specifically, would that give an argument to use the same HDMI cables from the same manufacturer? Do you think that would have kind of applied to what we're talking about here? Not really. Okay.
No.
Okay.
It's not like a manufacturer makes one device and say, okay, now we have to make a cable that's going to match that.
Yeah, good point.
Almost never happens.
Okay.
Never
Cool.
happens.
Fair enough. Well, guys, that's it.
Okay.
We're right at an hour. We made it on
That was
time.
good.
Thank you, Jeff, for the
That was great.
information and for the lesson. For those of you who are watching this recorded session on YouTube, perhaps, any questions that you might have on this stuff, feel free to type that in the comments. Also, give me some ideas of what you guys want to hear. Jeffrey and I are planning on doing these, periodically until, I don't know, until we get tired of it, which will never happen for me. I don't know about you.
Probably never run out of stuff.
Yeah, we'll never run out of stuff to talk about. But if there's anything real specific you guys want to geek out with or just ask about, feel free to leave that stuff in the comments. We want to cater these webcasts to you. We want to know what problems you guys are running into so we can give some advice on how to fix them. So don't be shy. Let us know. You can always email me directly, jason@murideo.com. And then Jeffrey, what's your email address?
Jeff@DPLLabs.com.
Super simple, guys.
And maybe next time, Jason, we focus in on I2C.
Yeah, that might be really fun.
I mean, not get crazy with it. Just show some of the basics of how it works in the line.
And we also mentioned too, you brought it up before, link training, which is a whole nother really cool thing about HDMI 2.1.
Yeah, link training is a good one. We have a special test now we added to our procedures. It's called true image testing, and it's all around link training.
Oh, cool.
So now we have an extra set of parameters to test to see if the unit will dive into link training. Now you think you're going to say, "Oh my God, the link training sounds really good," right? No, it's really bad. It's really bad.
Oh boy. Okay.
You don't want to go to link training.
Well, maybe we'll have to talk about that next time because that sounds like a whole other can of worms.
It is a can of worms. All right.
Excellent.
Very good. Thank you so much.
Any last word before we let everybody get back to their day? I don't think so. No more comments have come in. No more questions have come in. So I think we're good, guys. Thanks, Jeff, and we'll talk to you next time.